Welcome to the wonderful world of astronomy. This is chapter 12 on asteroids, comets, and dwarf planets. In this chapter, we're going to look at the smaller bodies that are in the solar system. This part 1 video is on classifying small bodies. This is going to be an overview of the things we're going to talk about in the rest of the chapter. Our goals for learning: what is the difference between an asteroid, a comet, and a dwarf planet, and what are meteors and meteorites? So let's talk about asteroids, comets, and dwarf planets. And here we see a picture of a comet, and we'll get into it later in this chapter, what exactly it is. Let's talk about asteroids first. Asteroids are rocky leftovers of planet formation. So when you think of an asteroid, I want you to think of a giant rock that is in orbit around the sun. The largest is called Ceres. It has a diameter of about 1,000 kilometers. So it's comparable in size to the state of California. There are around 1 million asteroids that are known. And when astronomers discover a new asteroid, they list it, they name it, and they put in a catalog, and we know of about 1 million of them. Small asteroids are more common than large asteroids. Asteroids, you can think of them generally as being big rocks, but sometimes they are just piles of rubble that are gravitationally bound together. All the asteroids in the solar system would not add up to even a small terrestrial planet. So as far as mass goes, there isn't that much asteroid material in the solar system. This graph shows you the sizes of the first 10 discovered asteroids compared to the moon. Comets are formed beyond the frost line. Remember in chapter 8, we talked about the frost line, which is the dividing line that divides the inner solar system with the outer solar system. It divides the planets that are rocky, the terrestrial planets, with the gas giants or the Jovian planets. So comets formed beyond the frost line. They are the icy counterparts to asteroids. Think of a comet, the nucleus of a comet, as a dirty snowball. It's basically a big ball of ice with rocks and debris embedded in it. We often think of comets as having tails, such as in the picture down below, because the ones that come near enough to Earth to see have tails. However, most comets do not have tails. Most comets remain perpetually frozen in the outer solar system, and it's only comets that enter the inner solar system that grow tails. Here is a picture of a sun-grazing comet. The blocked out circle in the upper right is where the sun is. This isn't actually the sun, it's just been blocked out, and they've put a white circle in its place. And it says this comet's tail is at least 2 solar diameters long, more than 3,000 kilometers. So as this comet is approaching the sun, its tail grows very large. And the next category of object that we're going to talk about in chapter 12 is dwarf planets. These are objects in the solar system other than planets which are round. And in chapter 7, you learned about Eris with its moon Dysnomia. And here it is again. Dwarf planets, by their definition, are small planetary mass objects. So they are comparable in mass to planets. They have a direct orbit around the sun. So that definition, that part of the definition would exclude Jupiter's moon Ganymede, which is actually larger than the planet Mercury. But it's not in direct orbit around the sun. It's in orbit around Jupiter, so that excludes it from being a planet. It is massive enough to be gravitationally rounded. So in the early formation of the solar system, these objects were massive enough to gravitationally pull themselves in to be round. And this fourth part of the definition is a bit confusing and a bit controversial, but it says it's insufficiently massive to achieve orbital dominance, which means Some objects that satisfy the other three parts of the definition are not massive enough to have gravitationally caused smaller objects to leave their orbits. There is no clear definition of what constitutes a dwarf planet, so whether to classify an object as one is up to individual astronomers. So this gets into these fuzzy boundaries between what is a comet, what is an asteroid, and what is a dwarf planet. And how do we distinguish dwarf planets from those other ones? Well, sometimes it gets a little bit fuzzy. Now, there are these objects called trans-Neptunian objects. These are objects that are beyond Neptune's orbit, and some astronomers will classify all of these as dwarf planets because they are rounded. They're massive enough, they are comparable in mass to planets, although the International Astronomical Union does not classify most of these as dwarf planets. But again, as I said a couple of minutes ago, sometimes it's up to the individual astronomer whether you want to classify these as dwarf planets or not. But you can see them in size comparison. All of these, with the exception of Pluto and its moons, were discovered since the year 2003. Here's one down here, 2002 MS4 was discovered in 2002, but its massiveness was not made known until a little bit later. So I mentioned fuzzy boundaries. All dwarf planets are classified also as either asteroids or comets. Dwarf planets that are officially recognized by the International Astronomical Union are listed here. So we have Ceres, which is also an asteroid. It was discovered in 1801, so it's in the asteroid belt. All the others are classified as Kuiper belt objects, which makes them also classified as comets. So we have Pluto, that was discovered in the year 1930, and Haumea and Eris and Makemake, that are all in the Kuiper belt. Then we have these objects, these three words that are very similar and that very tightly related: meteors, meteoroids, and meteorites. And here you have in a museum a very large meteorite that many children on a field trip are gathered around. This is an extremely large meteorite. So let's talk about all these different objects, and I want to focus on meteors, meteoroids, and meteorites. So let's start in the upper left hand, comets, which I've already mentioned. A comet is an icy body that releases gases as it orbits the sun. An asteroid is a rocky body, smaller than a planet, that orbits the sun. And now let's talk about these three things that sound alike, and let's start with a meteoroid. A meteoroid is a rocky or metallic fragment of an asteroid, comet, or planet. Think of it as a rock that is about to enter Earth's atmosphere. It's about to become a meteor. It enters Earth's atmosphere, and as it enters, there's much friction with Earth's atmosphere, and the meteor itself is actually the streak of light that we see when a meteoroid heats up in the atmosphere. So we see quickly moving across the sky this thing, and that streak of light is called a meteor. In ancient times, they called them shooting stars. And then this rock streaking through the Earth's atmosphere eventually hits the ground. Actually, most of the time it hits water because most of the Earth is covered with water. But when it hits the ground, once it makes impact with the Earth, it is then called a meteorite. So it's the meteor fragment that reaches the ground. So first it's a meteoroid. It streaks through the air and is temporarily a meteor, and then it hits the Earth and it's a meteorite. Meteorite impacts in cities and around people are very rare. Most of the surface area of the Earth is not inhabited. Cities are very kind of few and far between when you consider the total surface area of the Earth. So most meteors are going to hit in the ocean somewhere. Oftentimes they are, because of the magnetic field of the Earth, they are attracted more to the North and South poles. And in fact, most meteorites that are found on the ground are found in the white snow of Antarctica. But sometimes they make their way to where people are. This is a meteorite impact in Chicago in a home, and here you have the hole in the ceiling, and down below you can see the meteorite. So it fell from the sky, plunged through the ceiling, and ended up on the floor. This is a meteorite that was found on a farm in Kansas. So something like this, a huge meteorite like this, would probably fetch a price by somebody worth several $1,000,000. This is a meteorite, about a half a pound, that one day in the year 2010 smashed through the ceiling of a doctor's office in Virginia. There was nobody in the examination room at the time, but the staff of the medical clinic of the office heard a loud crash in the examination room, and they went in and found a hole in the ceiling and this rock. And there have been many meteorites that have been found around the Earth, and they are for sale. Here is one that I just today found on eBay, and this one, 299 grams, and it is for sale on eBay for $259. So what have we learned in this video? The difference between an asteroid, a comet, and a dwarf planet. Asteroids are leftover inner solar system objects, and by leftover, I mean leftover from the formation of the solar system. Comets are leftover outer solar system objects, so beyond Mars's orbit, beyond the asteroid belt. And dwarf planets are either of these that are large enough to be round. Remember, meteors and meteorites, and the other word meteoroids, they start out when they're rocks in space, they are meteoroids. The flash of light as it streaks through Earth's atmosphere is a meteor, and the on-the-ground remains are a meteorite. And in the rest of the videos, through the rest of chapter 12, we will explore these various objects. That is the end of part 1 of chapter 12. Have a great day.